What's poppin', dogs? Mr. Allen here. We got this dope problem here. We got to sketch the graph of a polynomial function with the following characteristics. I've got end behavior in this thing. I have a relative minimum at x equals -3, and I have a y-intercept of 0, 4. So how do I digest all this crazy amount of information? It's like information overload here, man, and make sense of this problem. Okay, let's do this. Let's calm down. Everybody calm down. It's just a problem, right? A math problem. So my end behavior can tell me if it's an even degree or an odd degree function. I have different end behaviors here, so it is an odd degree function. Now, as it goes to the left, it's going up, and as it goes to the right, it's going down, which means it's a negative lead coefficient for my odd degree function. So if it were, say, a cubic, it could look something like this, right? If it were, say, to the degree of 5, quintic, if you will, it could look something like that. Okay, well, let's see what it might look like. Anything else maybe in here that could tell us a relative minimum at x equals -3. So I'm going to have some kind of a low point at x equals -3, and that could be below or above the x-axis, really. But how about just for fun here? I'm going to throw a point below the x-axis. I'm just going to go right here. I'm going to say that's going to be a low point. And then I got a y-intercept of 0, 4. Hey, man, that is for sure. That is for sure going right here, right? Definitely going there. So let's see here. Could I make a cubic function work in this situation? I could have my relative minimum right there be that point, and then I could come on up and have the y-intercept somewhere in here, right? So let's see if we can do this. I can swing down. Whee! I can come up and pass through here, and then come on back down. Let's see if that fits everything here. This could possibly be my highest point. It could just pass through. It could have gone up and come back down to it. There's a lot of possibilities in these types of problems, which makes them kind of challenging. So does my end behavior match? As I go to negative infinity, is f of x going to positive infinity? Yes. As I go to positive infinity, is f of x going to negative infinity? Yes. This one, check. A relative minimum at x equals -3. Is this a relative low spot in the graph? Yeah, it is, bro. It's not an absolute minimum because my end behavior here, my arrows keep going down. It keeps going down, so this is not an absolute minimum, just a relative minimum. If I isolated this part, then that'd be a minimum point. That's what relative minimum means, all right? Or local minimum. Local is another word for it. And then a y-intercept of 0, 4. Am I crossing the y-axis at 0, 4? Yes, I am. Have I just met all 3 criteria? Ooh, that green check mark looks awesome because we've done it right. Yes, that's fantastic. That's wonderful. That's dope. You guys have a fantastic day. I hope you enjoyed this beautiful, beautiful math problem. See you dogs later.